In this video, we'll generate a trendline and polynomial of secant using the infinite product series. We begin with the dataset of secant. So array formula. Secant of the x values from negative 1.32 to positive 1.32. And the infinite product, which is the product of 1 over 1 minus, that's 1 minus x squared over pi squared n minus 0.5 squared. And the value of n is from 1 to infinity. So we can start from 1 up to infinity, which is good enough. 9 is good enough, so continue the array formula. That's for the numerator, that's 1. Divided by, so 1 over the quantity 1 minus x squared, so x raised to the power 2, divided by the denominator. That's pi squared n minus 0.5 squared. So that's pi times n minus 0.5 quantity squared. So the quantity pi times the quantity n minus 0.5. So n minus 0.5. And this is squared, raised to the power 2. And now we can complete the infinite product. So product from 1 to 9. And we copy this downward. And we chart this. Insert chart. And we use scatter chart. Column as label, row 1 as header. And we modify the chart, we show the trend line. Again, edit the chart, customize series, show the trend line. The type polynomial. The degree 8. For the label, use the equation. Here's the trend line and polynomial of the secant and its infinite product series expansion. The polynomials are the same, the trend lines are collinear, starting with the x to the 0, that's 1, 0x, 0.492 x squared, 0.481 x squared, so there's an error, 0x cubed, 0.311 x to the 4th, 0.302 x to the 4th, 0x to the 5th, negative 0.197 x to the 6th, negative 0.192 x to the 6th, 0x to the 7th, 0.246 x to the 8th, 0.24 x to the 8th. This error can be reduced if we increase the value of n up to a higher value, either 100 or infinity. These errors will be reduced and our line will be perfectly collinear. This completes the use of infinite product series to generate the Taylor polynomial of secant.